Aloha everybody. So this is a solution guide for the homework set in the growth and decay packet. Problem number one, identify the initial value, whether it's growth or decay, and the rate. So the initial value is always going to be the first number listed. So here we're starting with 300 of something. This is definitely going to be a growth because the number that's in the parentheses that's attached to the base of the exponent, this 1.34, that is larger than 1. So if it's bigger than 1, it's going to be a growth. How you determine the rate is you got to figure out how much larger it is than 1. It's the difference from 1. So in this case, I can get to 1.34 if I take 1 and add 0.34 to it. So my percentage growth rate is 34%. Again, it's this extra bit here that we want to convert into a percentage. So 0.34, which is not written very well, 0.34 is 34%. Kind of the same thing over here. We're starting with 125 of something, and we are decaying. We are losing pieces of that every day or every year, whatever units are here. And the rate, again, is its difference from 1. So how can I find that difference from 1? What would I have to subtract from 1 in order to get to 0.34? That'd be 0.66. So that difference from 1 is your percentage. So for this is a 66% decrease. For problem number 2, here I give it to you in a table. So if we wanted to come up with a formula for this, we could, and I will. But first, initial value, if you go back to the pizza problem and the carrot problem and the clover problem that we did, the initial value always occurs at your 0. So in this case, we're starting with an initial amount of 90. So if I want to write a formula for this, I would start with like y equals 90, and then I got to figure out what my rate is. And here, if you can look, you can see that as I'm going down, I am multiplying by 3. So this is an exponential one, multiplying by 3. So every step of the way, I'm multiplying by 3 here. So that is my base. So this is just like the rabbit population was tripling every day, or every month. So for here, again, it's that difference from 1. What would I have to add to 1 to get me up to 3 would be 2. So that is a 200% increase. And then again, this is a growth. As time goes on, we're getting more and more of them. And there is that first part. Problem number 3A. So you inherited land that cost you $30,000. That's my initial amount. And our mission is to figure out what the value of the land is in the year 2015 if the value has been increasing by 5% each year. So this is an exponential growth, 5% every year. It is going up in value. So again, we're always starting with that 1, and here we are adding 5% in. And again, 5% is 0.05. And we want to figure out how many years it's been. Well, from 1960 to 2015, that will have been, let's see here, 40 plus 15 is 55 years later. So if I wanted to simplify this, I could just kind of bring that inside part together as a 1.05 and raise that to the 55th power. And if I do that in my calculator here, I get $439,000. Wow. And well, $68, $439,068, and about 93 cents. So yes, having that and increasing it 5% each year, awesome. This one would be, part B is a decay here. So you start with 160 milligrams of caffeine once you drink that energy drink, and every hour you're losing caffeine in your system. So it's decreasing by about 12%. So you'd see 1 minus 0.2. How much caffeine will you have in his system after 3 hours? Well, that means you're going to have a 3 here, and then again, we will have an 8 there for the second part for that 8 hours. And 1 minus 0.12 is going to be about 0.88. So for the first part, the 3 hours, that goes to this one. And if you plug in and you do the math, you get 109.03, maybe 04, sorry, milligrams. And after 8 hours, you're at 57.5 milligrams. you have any questions, let me know. Thanks.